Welcome. My name is Channing Hambrick, and today we're going to be talking about embodied cognition. Imagine you're shooting a basketball. What do you imagine? Can you see it? Can you feel it? If so, you are embodying the experience, and that's what we're going to be talking about today. But first, let's take a step back and talk about some traditional approaches to cognition. Let's begin with the idea of Cartesian dualism, which is associated with this man here named René Descartes. The basic idea of Cartesian dualism is that the mind and body are separate, and this really set the stage to studying the mind as the locus of cognitive processing. And this idea has remained extremely prevalent within the field of cognitive psychology. This idea is directly associated with traditional sandwich models of cognition. In these models, the mind and body distinction is preserved, but it goes a little bit further than that. In these models, perception of our environment is a distinct stage of processing than the thinking or processing stage of what we do with that input information. And that is separate from the actual behavior that comes out of that cognitive processing stage. And this is also associated with the basic idea in which the mind is seen as an information processor. So you have input information from the environment, which is usually sensory information, that is input into the information processor or the brain, which then spits out a specific behavior. But then this thing called embodied cognition came along. The roots of embodied cognition go back to the early 19th century, but it was really popularized by Lakoff and Johnson in 1980. And they took their primary motivation from the study of metaphors, in which they noticed that a lot of the abstract concepts that we represent are talked about in terms of sensory motor specific representations. And so they said, wait a minute, the brain is not separate from the environment or from the body. The brain is situated within a body, which is itself situated within a dynamic environment. And so in the early theories of embodied cognition, several key factors are emphasized. One being that cognition is grounded in sensory motor processes. Since the brain is located within the body, it receives input from sensory motor processes, and these things influence cognitive processing. Moreover, the body and the environment are not just passively feeding into cognition, but they are actually active agents in cognition. And lastly, and perhaps most critically, the sensory motor systems that receive information also mediate its representation. So they don't just affect these representations, but these representations themselves are made up of activity within the sensory motor systems. So let's take a moment just to compare and contrast traditional and embodied approaches. So on the left here, we have traditional approach, in which perception, thinking, and action are all separate and distinct stages of the system. They can feed into one another, but they are distinct stages of processing within cognition. Let's compare that to an embodied approach. Of course, it begins with the mind, but the embodied approach emphasizes that the mind is within the body and the mind are both within the world. So we're going to be talking about this embodied approach. Now, let's talk about some of the phenomena that have been used as evidence in support of embodied cognition. First, let's talk about metaphors. And remember I said that this is the one of the first lines of evidence in support of embodied cognition, first proposed by Lakoff and Johnson in 1980. So let's start with an example. Think of how you might describe someone who is angry. Got it? You might say that they're hot-headed, or maybe they're burning with rage. And if you look closely, you can notice that both of these descriptions are really tied to temperature. which is automatically something that our body is familiar with. And so Lakoff and Johnson found a ton of these examples. For instance, you might say that time is running out. And so they proposed that our cognitive system is inherently metaphorical. And specifically, that conceptual representations are grounded in sensory motor experiences. That is, even very complex and abstract lines of thinking are directly supported by activation within sensory motor cortices. So this is directly in support of embodied cognition claims that really highlight the importance of sensory motor experiences in our day-to-day cognitive processing. Now let's talk about simulation. So let's go back to our basketball example. Did it almost feel as if you were simulating shooting a basketball yourself? It likely did, and that's because that cognitive representations, specifically of actions, are often thought of as simulations. So that whenever we're representing these concepts, the representation is actually composed of simulations of the event itself. And a lot of this support comes from investigations studying action imagery, observation, and execution, and particularly while a brain scan is being conducted. We can see here on this image on the right that brain activation for motor imagery, action observation, and motor execution are all very overlapping. So the brain responds similarly to if you are imagining running, watching someone else run, or running yourself. The brain would respond very similarly. So this has been used to support the idea that our cognitive representations of action sequences are actually composed of simulations of those actions themselves. But how might this be? It's thought that mirror neurons are responsible for this effect. Mirror neurons are neurons that respond when both observing someone else complete an action and when you execute the same action yourself. So it's thought that these neurons are specialized to respond similarly to motor imagery, observation, and execution. A lot of the support for embodied cognition also comes from language comprehension, such that comprehension is directly tied to embodiment. So what do I mean by that? So there is evidence that comprehension of action verbs is associated with activation in the relevant motor areas of the brain. So for instance, hearing the word catch would be associated with activation of the hand-specific sensory motor areas within the motor and sensory motor cortex. This idea has also been largely supported by studies showing what are called action congruency effects. In these studies, someone is presented with a action word that is specific to either the hand or the foot, and then they are asked to respond to an unrelated target stimulus by using either a hand or a foot pedal response. So let's look at an example of what that might look like. So for instance, according to this action congruency paradigm, hearing the word run would be associated with activation of foot-specific activations within the motor and sensory motor cortices. And that activation would lead to a facilitation of the foot pedal response. In contrast, if someone is presented with the word catch, that would be associated with activation of hand-related representations within the motor and sensory motor cortices. And that activation would facilitate a hand response. So this is what's known as the action congruency effect. This has been used to support the idea that sensory motor activation is directly tied or even necessary for comprehension of action-related words. Embodiment is also critical for social cognition. Specifically, it's been proposed that embodiment is a way for us to understand the emotions and mental states of others. Specifically, it's been implicated in what is known as theory of mind, or our ability to understand others' mental states. It is thought that the representation of others' mental states would be very similar to our representation of our own mental states due to embodied mechanisms, and that would allow us to better understand the mental representations and processes of others. Embodiment has also been implicated in social mirroring. Imagine your friend comes to you upset. Your natural response might be to mirror their facial expression. It is thought that this is due to those mirror neurons we talked about earlier. It is thought that observing a facial expression in another closely resembles the actual execution of that facial expression in ourselves. So this might directly facilitate empathetic and mirroring responses within social contexts. But there has been some controversy. So let's take a moment to address some of the current controversy within the field of embodied cognition. First, let's talk about publication bias and null findings. So one of the issues that is currently kind of plaguing the field of embodied cognition is the fact that it is a very popular approach within recent decades. That means there is a lot of pressure within the scientific community to publish results that are in accordance with embodied cognition as a popular paradigm. This means that it might be more difficult or maybe less desirable for scientists to publish findings that are in opposition to the claims of embodied cognition. We can see such an effect within the action congruency paradigm. In a study by Miller et al. In 2018, they did several studies investigating the action congruency effect in language comprehension that we discussed earlier. However, over a number of experiments, they actually failed to find this congruency effect. And it seems to be directly at odds with a lot of the other published research. But does that mean that this is just a bad study, or is there something wrong with the research publication process itself? Within the field of psychology, there has been a widespread publication bias. This bias means that it is harder to publish studies that have null findings. That is, findings that do not find significant effects are often less desirable for journals to publish. So this means that it is not the case that null findings rarely happen, but rather they are rarely published. So this means we actually don't know how many null findings there have been within the field of embodied cognition, since many of these, if not most, never reach the editing table. Another issue that is currently being discussed within the realm of embodied cognition is the fact that a lot of the theories are quite vague. So, what does any given paper mean when they say embodied? Moreover, there's been widespread use of terms slightly different than embodied cognition that are talking about similar constructs. For instance, people might say embodied, situated, or grounded. So what do those really mean? Are they all talking about the same thing, or are they talking about something different? It is certainly the case that even within these three labels, papers are often using slightly different working definitions of embodied, situation, and grounded. So there's currently a lack of clarity on what is actually meant by using these terms. There's also a very wide array of hypotheses associated with each of these paradigms. For instance, a hypothesis might be called strong if they are saying that everything is 100% fully embodied all of the time, or they might be called weak embodied hypotheses if they propose that there is only some sensorimotor embodiment in certain contexts. And so there is a vast array of the strength of these hypotheses across the body of research. And lastly, it's unclear in a lot of these cases what the actual predictions are. If we're using a strong or a weak, or an embodied or situated or grounded approach, it's often unclear what exactly the predictions in any given study are. So currently, as the field stands, there are currently a lot of very vague approaches, and much more constrained hypotheses and predictions are needed to further this approach. There's also the issue of timing and specificity. That is, the main question here is that, is embodied actually required? And so one of the kind of principal questions surrounding this requirement question is the time course of sensorimotor activation. So is it the case that sensorimotor activation happens after the concept is called to mind, or is it required for the concept to be represented at all. Of course, this means that we really need to get a look at the time course of this sensory motor activation, which requires very sophisticated equipment that is still currently being developed within the field. So in this way, establishing the time course of sensory motor activation is critical for establishing the causality of embodiment within cognitive representation. There's also the issue of specificity. So is embodiment actually required? Does that mean that it happens all the time? Does it happen in all contexts or only in specific tasks? So it is certainly possible that embodiment within sensory motor areas only occurs within specific contexts or specific tasks. It may be the case that sensory motor activation only occurs when a task is very familiar or very rehearsed, or if it is especially relevant to completion of a specific behavioral goal. This is currently something that is often underspecified within embodied approaches, but is beginning to gain more popularity within current research. And lastly is a long-standing issue of abstract concepts. So it might make sense for us to embody representations of things like shooting a basketball. But what about more abstract concepts like love or justice or peace? How would we represent those concepts in a sensory motor way? It's currently unclear, although certain researchers have proposed that even these abstract representations are tied to more concrete instances that can be associated with those more abstract ideas. But it is currently not very well understood and is still an area of active research. So what do we do now? What is the way forward? Perhaps a viable approach would be to be less extreme and propose that embodiment is less necessary. So one thing we could focus on is emphasizing the benefits of what the embodied approach has brought to the field of cognitive psychology. Specifically, focusing on the fact that cognition really is tied to the experiences with the body and the body's situation within the physical environment. But this does not mean that we need to take a fully embodied stance. Rather, we can simply focus on the fact that some aspects of cognition are situated and grounded. We can also focus on the idea that embodiment might be an associated but not always necessary process. And a way to do this would be to focus on finding those specific contexts and tasks that elicit particularly embodied representations. And lastly, we need to emphasize the role of both embodied and disembodied representations. So what do I mean by that? So we can see here two different models that have been proposed. So let's look first at model A on the left. Here, this would be considered a distributed only model. So within this, action, sound, motion, color, shape, name, and taste are all represented by unique sensory motor cortices. So specifically, the representation of action would take place primarily within those action-specific modules, while the representation of motion would only take place within areas dedicated to the representation of sensory motor motion information. But we could argue that we need all of these aspects of representation to be integrated into one holistic picture in order to accurately guide our behavior. So let's take, for instance, the example of grabbing a wine glass. So it's important to know the general shape of the wine glass so that you can accurately calibrate your grasping behavior. But it's probably also useful to know the muscle groups that you need to actually reach and grab the wine glass. It's probably useful to know the color of the object that you're reaching for, as well as what you would call it, and probably even, if it's wine, what it tastes like. So in this way, it would be useful to have one area that is able to integrate all of those aspects of sensory motor activation. So that's where the distributed plus hub model comes in that we see on the right. Here, you still have all of those areas that activate preferentially to different aspects of sensory motor experience, but they are all integrated within one amodal hub. And here, amodal means that the representation code within this brain area is not specific to one type of sensory motor experience, but rather all aspects of sensory motor experience can be represented within the same code within this amodal area. So it is currently thought that this amodal hub is a form of disembodied representation. Since it is not directly dependent on one type of sensory motor representation and integrates information across sensory modalities, it is disembodied, but it is very important, obviously, for guiding our general understanding and behavior within our physical world. So where does that leave us? So it's obvious that our sensory motor experiences and our surrounding environment directly inform cognition. And we can say that embodiment certainly plays a direct role in how we represent actions and understand the actions of others. But it may not always be necessary, and more precise theories are needed to understand the causality and context specificity of embodiment. And lastly, understanding how both disembodied and embodied representations work together is likely key to understanding how we represent things within our cognitive system. Interested in reading more? Check out these sources. Thank you.